So today we're going to look at the difference between a linear and a nonlinear function equation. And the difference between linear and nonlinear is that a linear function or equation is going to be a straight line. So it's going to be diagonal in a positive direction, diagonal in a negative direction, or horizontal for it to be a function. It's going to have a constant rate, so it's going to go up by the same amount for the x's and y's. It's also going to be in slope intercept form, which is y equals mx plus b, or it's going to be in standard form, which is ax plus by equals c. If you see it in either of those forms, that means that it is a linear function. Some examples of linear functions are going to be, this would be an example of a linear function because it's in slope intercept form, so it has y equals 2x plus 10. This is another example of a linear function because this would make a horizontal line and it would have a slope of 0. This would also be a linear function because even though it does have an exponent, it's not attached to the variable, it's attached to the y-intercept or that constant. So if I were to simplify this, this would be 3 to the third power, which means 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So if I simplified it and put it into slope-intercept form, I would get y equals 27 plus 7x, which is a linear function. This is an example of where it's in standard form, and to get it into slope-intercept form, this is an example of a linear function, but to show that it is a linear function, what I did is I subtracted 4x on both sides to get y by itself. I get 6y equals negative 4x plus 12. I divide by 6. So then I get negative 2/3 because negative 4 and 6 have 2 in common. So if I divide those both by 2, I get negative 2 over 3. X plus 2, because 12 divided by 6 is 2. That is in slope-intercept form, so it is a linear function. So if I had an equation where it was 4x plus 6y equals 12, that would go underneath my linear function. Now, an example of something that's a nonlinear function is it's not going to be a straight line. It's not going to have a constant rate that it goes up by, and that it's not going to be in y equals mx plus b, so it's not going to be in slope-intercept form. And a lot of the times, nonlinear functions has exponents that are attached to the variables. So for example, this is a y equals 2x squared plus 2. That is a quadratic function. So you would see that it's a U shape, and that would be nonlinear because it's not a straight line. This is an example of a cubic function. You'll see it's kind of like an S-shaped graph, and this one always has this 3 for its exponent attached to the variable, which allows it to be a cubic function, which is considered nonlinear.